Alright, so we were talking about the inventory. How do you use the inventory? Why do you need an inventory inside your game? Yeah, we were looking at this example. So when you press the button, it's actually you control the move of this virtual human, of your avatar. So this is from a Unity package. It's a third-person controller, so you can just move this person. You don't have to worry about that part. What we focus on here is how can you set up different inventory item? How do you pick it up, and how do you update those status within your system, within that human? So here, as you can see, if we maximize the game, if you hit the I button, you will find we have a list of the inventory here, but it's all empty since we pick up nothing now. So what you want to do is, first you need to pick up the item. You want to implement the functionality whenever you enter that or you touch that inventory item. You want to pick it up, and then after you pick it up, it's not only you update it in the thing that the item disappeared, but also you need to update internally. So there are a bunch of ways to make such an inventory, because you can use many data structures. You can use those collection classes, list, or if you want some mapping, you want the item name mapping to the item number, you can use map. You can use the dictionary. You can use things like that, or key pair value. Yeah. So there are a bunch of ways. So yeah, let me show you my ways of doing that. But you please be aware that you are not restricted to the way I did this. Okay, you are encouraged to have your own way. But this is maybe a point that you can start with. You can try this first, and then you can implement your own. You think some other data structure is better for this kind of task, you can go ahead and do that. Alright. Okay, so here let me make this out, and then we pick up the red one. That's the inventory item 1. So whenever you pick up the right one, you will see we actually have a inventory item 1, and the number is 1. The item number, the amount of the item is 1. And if you pick up another one, it's gonna be 2. Alright. So it won't create a new item on there. So instead it updates the existing item here. It's just updating the amount. Okay. And when you pick up the green one, it's gonna be item 2. It's the same. And this one is kind of different. So right now we have 2 inventory item 1 and 3 inventory item 2. Item 2 is like the green one. And then if we pick up this one, this is actually kind of different. So that's a group of objects, kind of like you picking up the armor, the bullets. Okay. So usually you pick up a group of them. It's not like a weapon. It's a collection of objects. So let's see. When you pick this up, you actually see 10 group inventory item. So that's 10. Right. Yeah. So this kind of functionality is very common if you ever played any game or first-person shooting, some other games. You pick up items. Okay.
Could you have the UI set up where let's say that the player only has a finite amount of have it set up where it's like you can only take a certain number of it, where it's like you can have the code set up whereas you have 5 slots left of space. And you want to take
slots?
Yeah, like that's for an example. Like you have like 5 measures of this much space left, and then you wanted to pick up 10 bullets, but you can't take more than 5. So
yeah, sure. You can always set up that kind of restriction here, but this the example here, I didn't do that. It's just for the purpose of demoing this functionality. Of course, you can set up like the space.
Yeah.
The inventory has the space, so you need that restriction. When you pick up something, you need to go back, check inventory. Do I have enough space for that? So you have to predefine the limit of that inventory. You can have usually you can so Warcraft, things like that, 9 of them, right? So you just need to check. So it's just a precondition before you can just check the precondition before you pick up the stuff. And if you do not check, however, you do have something here. You do have a limit here. It's 9 slots here. So if you do not check that, and you have only 9 here, so what happens? Depends on your implementation. What happens to be the override? And you pick item 10, and then it put it in the item 1 space. If you are going to do it through the iteration, and yeah, some error will happen. But if you that's a good question. Thank you. So just you need to check that limit. You can set any kind of limit. It can be space limit, or it can be weight limit. Like different item has different weight, things like that.
Because it's like I think with a lot of games these days, they'll employ some form of inventory mechanic where you're limited by somewhat of that's like let's say for example a lot with Bethesda games, they usually have limitations on inventory based on weight.
Yes, that's the one fun point of that. You have to manage the space, manage what kind of things you want to. You have to kind of decide what you want to give up, what you want to pick up. Yeah. Okay. So here, let's see how are we doing the implementation. That's a control. Let's see, where do I put the inventory script? Okay, it's here. So when we were talking about this kind of inventory, our operations to the inventory will include those operations that you can usually think of when you are trying to deal with a database. So think about a database. Think the inventory as a database. But here it's much simpler than a complex database. It's just the data structure here we are using. But we still need to do first creating that inventory. We need to be able to adding items to the inventory. We need to remove items, and we need to set the size. Sometimes it can be dynamic, sometimes it has some limit there. Yeah. And how about, and also the if we want to pick up multiple items, how can we implement that? How can we identify whether that is like multiple items or a single item? And also, if you notice here, we have a quick item. So basically, we have this 9 slots on the inventory, and this 4 kind of like the quick access to some item. You can set it as like the least used item, the most used item, or the most recent used item, or you can just simply make it like the first 4 items here. It's for you easier for you to access. So that's one possibility of that. Let's see, how do we implement that inventory? So first, to implement that inventory, we need to define several of them. First, this is actually the inventory object, and here this is the size of the inventory, and this key value pair is very important because it basically you can use the item. It gives you that kind of mapping, the relationship between the item and the amount of the item. So whenever you want to find out what is the amount of the item, you cannot go into here. You can do this you can do this query. You can go through that and check what is going there, and how many item count is there. What is count of the item? So when you trying to initialize the inventory, what you do is you first initialize. You go through here it's the inventory size. So here we use 9 as the size, and you kind of go through. You initialize everything with 9 of them, right? So inventory items, you have 9 of them, but when we initialize, we put everything as empty. And key value pair. So items I, you have now have a ID of that, and item count. So basically, item count is mapping the ID to the amount of the item. For example, if the item object item object 1, ID is 0, usually it's 0. And here we're mapping 0 to 0, because we basically, when it's empty, we pick up nothing. And quick, to here, this part, if I is less than quick items dot length, we put quick items I equals to inventory items I. What are we doing this? Why are we doing this here? Can anybody tell me? Does any sense?
Set those to empty as well.
Yeah. So it just put the very first, because the quick item length is 4. So it just pick up whatever is the first 4 items in the inventory and put it as a quick access. So that's it. So it's a simple implementation of quick access. But sometimes you want to do most recent used, or most used. That depends on your strategy. But here it's the simplest one. Okay, so when we actually hit one of the inventory item, we want to be able to add that item to the inventory. But before here, another thing. Before we're talking about add to inventory, we need to know where do we use this add to inventory. So it's here on trigger enter. You can guess what's happening here. It's like whenever you hit something, trigger enter, then you call this add function to put that to put that information into the inventory. The information comes from whatever object you just hit. So here, what we're trying to do is, first we judge if the tag equals to the inventory item. So we set up all of our inventory item with the tag, like inventory item. No matter it's inventory item 1 inventory item 2, 3, a group. We all put them as with the tag like inventory item, so that when you actually hit the item, we can go to this block of code. So what we do is we forget about the debug. So it's if it's a group, if the object name contains a group, then you kind of need to get the amount. And then you call this add to inventory amount and object. You call this function with its amount and this object you just hit. And then you destroy this object, because when we pick up something, we want it to disappear in this game thing. Okay. And then let's see, when we call add to inventory, what's going to happen? We have this loop here. This whole functionality is basically a big loop here. So when we are going through this loop, we use this inventory items length. Basically, it's 9. So if we find something, we find the first empty. When we find the first empty slot, okay. First we go through that. If we find there's something it's not empty, means something is already there. Something's already there. Then we just update the number, the amount, because when you pick up item 1 and you pick up another item 1, you don't want to create a new one there. You just need to update the thing you have already picked up. So here is the value plus how many. You have a new amount. Then you update the new amount in this key value pair. Because you use the ID of that item. Maybe it's the first. If it's first item, then the ID or the index is 0. And then you update that in the key value pair. You got the number and break. So this is dealing with when the item has already exists. When the item exists. And here, this is another situation. So this is another situation when it doesn't exist. When we go through it and it doesn't exist. Here you actually, you reach the point that you reach the first slot that is empty. So you can have the sense that, so I go through the first several of the item, and none of them match this object name, so it doesn't exist in this current inventory. Then what we do is create a new one. In order to create a new one, you have several things you need to update. First is the value. First is the inventory item. You kind of need to put the new item in, and you update the item the 2 key value pair. First key value pair is the index mapped to the name of that object. The other key value pair is the index mapped to the amount of that object, so that you can use that index to check the name and the amount of that item, inventory item here. So 3 things you need to update basically. First is the inventory item and item count. The last 2 is 2 key value pair, and the inventory item is actually the item itself. So whenever you're doing the add, modify, delete, something like that, you always remember to update this 3 data structure, this 3 value. Then you kind of you will be able to implement this add function. And then also removing. Let's see when you need to remove the item. So when you pick up one thing, alright, you have I. If you hit this button, if you are using this item, because some item it's not like the equipment you used to strengthen yourself, or sometimes you you give up this equipment, or sometimes you just use that equipment, like you're taking some heal of your health HP. So when you hit this button, you will use this inventory item. At that moment, what we need to do in the GUI, what we need to do in the game thing is we instantiate a new item object. But at the back end, what we're going to do is the same. We update those 3 different values, the 3 different data structure, Now let's see, remove. Okay, so we need to, when we call the remove function, we need to give the name of the object we want to remove, and we need to give the amount of the object we want to remove, and then we use this loop. To go through the inventory item, and if we find that item here, inventory items I dot equals item, then we know this I will be the index or the ID, whatever you want to call, will be the index of the item we want to remove, because that's basically how we assign it. And we got this I, then we are able to update this item count I. It's a key value pair, remember? We want to update the item number and the amount with the new amount. And this new amount here is the original amount minus how many, like how many you used. So it's original amount. But and then we update the amount in the key value pair. That's simple. But there's one situation you need to consider is when we use it up. When we use all of the item, you want to do something different. You want to put the empty back there, empty again, and then you want, because that's empty, you want to kind of reorder that inventory. You want to put the empty. You want to move the thing after the empty, like back to the empty slots. Yeah. So that's how you do the remove. And this reorder inventory, you can guess what's happening here. Reorder inventory item. So it's a loop, okay, going through the inventory, and when it's find empty, but if the empty plus 1 is not empty, you just like kind of remove one thing back, move one thing back, put the empty plus 1 to the empty slots. So you can guess what's happening here. I'm not talking about this implementation here. Okay, that's remove from the inventory. That's a reorder inventory. And this is a set quick item. As I mentioned, we have a very simple, really simple implementation of the quick item. We just pick up whatever is the first 4 items in the inventory. Put them in the inventory quick access menu. So when the update function is, we check if we press the I button, and then we show inventory. We show the inventory. We show the GUI. Here, one more thing I want to explain in the inventory is when we actually press the button, what happened? It's here. inventory GUI. So the GUI layout button, this button is, we initialize 9 buttons there. Everyone is corresponding to one item inside the inventory. Here we only have, if you dig into the code, dive into the code, you can see we only set up a reaction to the very first inventory item, like this. Okay, so we have 2 items. If you hit the item 2, actually nothing will happen because basically I didn't implement that. But if you hit this button, you will have things generated. You have something you use. So it's this. We have a if button. So if this actually GUI layout dot button, it will return a Boolean value, true or false. Whenever you press the button, it's gonna return true. Otherwise, it will return false. So it's this part. This is the very first button. Yes?
Buttons work differently now because of the new UIs.
Yes. But we have UIs there. This is a way I was trying to let you know the logic behind using the code, using the code to write the GUI. And this GUI function actually is available since Unity 4, I guess, Unity 4 or 5. Yeah, and now it's several versions after that. If you're interested in that, you can see that. But here I just want to show you the logic when you're writing the code. I want you to know the basic structure of the code, how it works. So you learn that through the code rather than through the UI. Okay. So what we're doing here is when we press the button, we instantiate the new object with the item, and then we remove 1 from the inventory. So that's basically what we did. You can use a for loop here to implement every single reaction to each of the button. Here is we only do that in the first button. You see, I think you are pretty familiar with this functionality because basically we're using that every week. Instantiate. Sometimes we use that to generate bullet projectile. Sometimes we use that to generate this function, this inventory items. Yeah. So that's it for this. That's everything I want to mention for this inventory item. And any question on that part? Okay. If there's no question, because this is pretty easy, it's just the logic, how you create that system with different data structure. But yeah, as I mentioned, you do not have to be restricted to this implementation. Because sometimes this implementation is really stupid. So for example, the button stuff, the button part, basically because those buttons, they have very similar behavior. You just need to use a loop to implement that instead of list the functionality for each button. Okay, now let's finish this part and we will go to something more interesting. It's AI. We want to create some AI-like stuff to our enemy or friend's army. Okay. Now let's start here. Okay, we're here. So this is the same thing what we as what we talked just now. It's an inventory item, an inventory pickup stuff. But now we are trying to kind of improve that. We want to make it more fun. So what we do here, what we're trying to do in this topic is first we want to create a nav mesh. It's a navigation mesh. Basically, what is a navigation mesh? It's something, it's already built in Unity. You don't have to worry a lot about that. So it's a nav mesh. So it's kind of, you have this ground here. We know where can we step on, where can we walk. But here in this part, we don't want the character to like walking here. So it's something just specifying this kind of setting in your game. So you have a plane or terrain, something like that. You want to specify where can a character walk, where we don't want to allow the character or the AI to walk on that. Okay, not character. So character is controlled by you. But we have something AI, we can have set some kind of auto patrol the movement for the AI, for the character or the enemy. So you want kind of let the enemy move around. However, sometimes when the AI move around, you don't want to let the AI to fall into some hole or hit by some obstacle, blocked by some obstacle. So it's just, sometimes when it's do the AI, I don't know if you see that, some AI just, when it hits some obstacle, it's just doing this, keep doing that. Okay, so we don't want that kind of thing to happen. So what we do is, in Unity, there's one thing called navigation mesh. Navigation mesh, you basically define where you can go, where is the obstacle, and then you define what is the range you can go on. Like when some part of the terrain has some difference in the height, maybe you can step on that, or you cannot step on it. You can specify those kind of rules there, and then you can see we can use something inside Unity to let the AI move around in the mesh, and then we want to give some artificial intelligence to that AI. Like we have different status. We make it combat in the combat mode, in the patrol mode, in the idle mode, and some convert in between, some change in between. Okay. So this is the same thing, exactly the same thing as what we talked. I want to build a project based on that, so let me duplicate this thing. We call it chapter 5, start over. Yeah, first let's talk about something about AI. So anyone here has some sense about AI? How we implement AI? Yes?
State machine?
Yeah, find state machines. State machines. That's one thing. Basically, what we want to use is kind of a decision tree, behavior tree, state machine. That's two popular way to implement the AI, to design AI in the game. And another thing, so if you pay attention to the tech news or something, another AI is very hot recently. It's machine learning, deep learning stuff. So that's basically, it's another thing here. It's different from here. So it's kind of a pattern recognition, image recognition, face recognition, patterns. That's and play the Go, AlphaGo, things like that. That's a different AI with what we talked here. That's a kind of, you train the machine. you train a mathematical model for the machine, and the machine can use that mathematical model to make some judgment, prediction, and recognition, classification. But this is what we give the AI, give the behavior. We want the friend or the enemy inside the game to have some behavior, behave like a friend and enemy. So like when it's patrol, when it meets an enemy, during its patrol, it changes itself to the combat mode, something like that. Okay. So first, let's talk about how can you bake a nav mesh in the Unity. Okay. We don't need this wars anymore. Instead, we want to create some cube and make it larger. We want to use this kind of like the ground. We don't want the original plane. Okay, and we copy paste this cube to make it have more place to go. And we want to move this stuff a little bit over somewhere. Okay, so we have a whole bunch of items here. Remember, that's our basically our inventory item, right? We can pick them up. Sorry. That's our inventory item. And now we kind of use this inventory item like some obstacles to block the movement of a AI. So we put it at some random places. But if you still want to use something as the inventory item, that's fine, but then you will see. Okay, and then we put one more here. Okay, so basically this is our like the map of our game. It's gonna be something like that. There's some place you can. There's some certain place you cannot. You don't want the AI to go there, like this hole right here. Right, this hole right here. You don't want to make it fall. So let's see. What we want to do here is we select the ground we want to bake. We select the area that we want the AI to step on, and then you select this window here, and then you will find a navigation item here. You click this, you have this option here. Basically, you can select different filter. Basically here now we're using all the items we selected. Or what you can do is you select every item and you bake everything that is marked as terrain or everything that has a max renderer to bake it. But now we're baking everything here. We're baking every cube here. Here, bake. We have several different options when you are doing the bake. There are some parameters you can play with. I'm not gonna explain all of it, but you can tell what they're used for. So like this agent radiance. It's agent means the AI agent. It's when the AI is step on this terrain, step on this path, how large do you want the AI to be? And the height of the agent. And then you can play with the slope, the step height. Step height means if two parts of the terrain, two parts of the ground, they have some difference in the height. If it's too much, you don't want the AI to step on it, just to fake. And if you want to be realistic, you kind of need to set up a limit. What is the height for the AI to step on? And some of the ground is the height is above some certain level, but below some certain level. Here, you can make the AI jump on it instead of step on it. So that's all the things you can play with the parameters here. And easy. You just need to, after you set up all this parameters, sometimes you just use a default like we're doing here. After you set up this parameters, you just hit the bake. I'm sorry. Yeah. In order to bake them, you have to make the thing that you want to bake static. That's very important because physics means just like something predefined there, like the past, it won't change. Like the school, the hallway, the classroom, it won't change a lot during the game. But sometimes in the game, there are many stuff that change a lot dynamically. You don't want to bake them into your system. So you just want to bake the static stuff. The static stuff won't change. So first you select each of the item, the cube, each cube, we use that as a ground. And then here, at the right up corner, you have this option to check this static. When they're static, you can actually bake them. See? So this is gonna be the blue area. The blue area is what we baked. So that's the area that the AI can step on, can walk on. So if you change the radius of the AI, let's see, it's a 0.5, right? Let's see if it's a 0.7. Okay, when I hit bake again, pay attention and see what is the different. Tell me what is the different. Notice the difference? Yeah. The area becomes smaller. The walkable area becomes smaller. And the edge becomes thicker. So why did that happen? Because the radius of the agent, it becomes bigger. Like it's a huge person, so you don't want it to fall into that hole. So you want to keep it a little bit more away from the edge, things like that. And if you want, okay, the obstacle. So here we only bake the ground, but if we want to do something, make it as an obstacle. Like if we want to pick this green, this red one, the green one, and this green one. We want this for obstacle. we select all of them and bake again. Oh, we need to set it as static. You can see. So it becomes even smaller. The blue area becomes even smaller because we have a lot of obstacle there. We don't want the obstacle is something of area we don't want the AI to get into or getting any closer. So, but this seems too big. So we want to change like the radius to maybe 0.3 or something like that. That's actually better. Yeah. So as you can see here, this red one is obstacle. This green one is an obstacle. The green one, this red one. But this blue, this blue and green, this one, they are not obstacles. So it's not baked in there. And they are not, if you look at the inspector, those obstacles, they are static. But this thing is not static, so it's not baked. Whenever you want to bake an environment, you kind of want to set up. I mean, if you want to move the chair in the game, like chair can you move around, you don't want to bake it. And if you are, what you can bake is the layout of this ground. And the wall can be baked because it's won't move. The door can be baked. Person, chairs, table, maybe that table can be baked, but this table, this chair, definitely you don't want to bake them. Yeah. So here it's the blue area. It's wherever the AI agent can step on. When I talk about AI agent, it's actually the Unity's AI agent. Unity have already implemented some sort of AI in there. So when you want to move an agent from location A to location B, if you have this match, it will automatically find a task from the location A to location B, like this location. If this red one is the location, oh no, we don't want to put location here. So let's do another thing. Let's create and let's create the points. Let's create some waypoint here. So it's like a waypoint is a concept that there's some waypoint here. When the agent arrives at waypoint 1, we want to go to point 2. After it arrives at point 2, we want to go to point 3, something like that. But now let's try only 2 of them, okay? Let's put this as the waypoint. This is waypoint 1. This waypoint 2. And we make it the sub-objects of the waypoints so that it's easier to manage. Okay, so we have 2 points or 2 locations here in this 3D environment. We want the agent move from its wherever it is to point 1 and then to point 2. Okay, let's do this. And when it's actually moving, we want it to avoid some certain obstacles. Let's put all of them as obstacles and make it more fun here. This. Alright. First they are all static, and then we pick. Okay. So all of the inventory items, they are obstacles now. So when the AI actually move, it won't hit them. Let's do another thing. No, don't do that. Okay. All right. Okay, so inside this folder, this game folder, actually in the prefab, if you download that in the prefab, we actually have some. I've already imported some character with the animations, idle, dancing, and moving, running, things like that. And you can find that in the asset store, or you can make it yourself. It's fine. Just when you are doing that, you have the resource, but it came from anywhere. Okay, and let's put one of them here, the skeleton. So we want to make it as an enemy. But now, I don't think today we have time to talk about the enemy, but today I will show you how to use the nav mesh to make it navigating around this area. Okay. So here you can see we have a different animation here. We have attack, run, we have a die, dance, things like that. We will use this dance, kind of like the idol.
Can we see the dance?
Can
we see the dance?
Yeah, I can show you later. Now let me finish what I want to talk today. You can download that from the. Oh, I forgot to upload it, but I will do it after the class. You can download it from the D2L. And then we kind of add a component. So it's nav. Yeah, it's nav mesh agent. So when we talk about, when we set it as a nav mesh agent, when we add this component in, it's actually Unity knows this character is gonna be the AI. It will use. It can help it to navigating through this area. Yeah, so the radius is 0.5. We kind of want to put it like 0.5. Okay, the skeleton. Yeah, so a nav mesh, and we want a script. New script, call it simple nav test, and then we want to kind of implement something here. Okay, this is the one. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create function. So we want to kind of make it a create fun move to. Okay. Let's put give it game object. Yeah. Object. Game object. Destination. Destination. And then we want kind of have a public variable. Game object. Destination. Then when we move it to the destination, we kind of yeah, let me check. Yeah, first when it's moving, we want to play an animation, but it's not gonna be dance, it's gonna be run. So basically what this statement does, it gets the animation component from this object and then it play that animation, run. And it will use the destination dot transform dot position, I guess. Yeah. So this is what we did. Let me double check. The position is a vector of 3. So this function, the nav agent, which is predefined in the Unity AI, Unity Engine AI, nav mesh agent. So it has a function like set destination. If you calling this function, it will make that agent move. It will make that agent move from the current position to the target position, and it will take a vector 3 as the input. Let's make another boolean move. We initiate like false. Whenever I make it public, that means maybe I want to change it later in the inspector. I shouldn't make them like, I should put this as this. Okay, so it's a simple test how we play with the AI agent and the bake. Okay, basically now this, yeah, I want make when it start, I want kind of make it play the idle animation. So I want it to play the dance when it start. Okay, so this is basically a simple script. What it does is first when it start, it plays the dance like the idle. And then when it's going through the update, whenever we want it to move, we check the move, and then it goes to the move to function. In the move to function, first it plays the run animation. Then it calls the name engine extend destination position as a position of the location we want it to go. Okay, if we go back here. If we go back here, you can see here destination basically it's none. It's nothing now. We can set it during the runtime, and we can play with that. See, if you can see, this skeleton is actually playing this dance animation when it's idle. Okay, when it's idle. Kind of funny. And now we want to make it move. The skeleton, we set the destination about this one, the waypoint 1. Okay, let's set that. Waypoint 1. Still, it's not moving. But if we check this, okay, something wrong here. It should go to that position. Ah, no. Yeah, I forgot this part. I knew I forgot something. Sorry. Here we also want to set up the name engine to itself. That's important. Alright, stop dancing and start move. Waypoint 1. Move. See, it's actually moving, and it's avoiding those. Obstacles. Yeah, it's getting in there now. See? So that's how we make it move. Okay? It will automatically avoid first those obstacles, then those holes. It won't fall down. But for this character, if you remember, it's still controlled by us. So whenever we press a button, it still hit the obstacles because it disappears because it's still the inventory item. I haven't changed that part yet. And if you actually keep running here, you will see what happened. It will fall far away from us. And if you want to see how is he doing, you can double click. It's actually keep falling. You can see this Y is keep going to minus 1,000, 2,000, things like that. And we do have an animation for fall. So that's funny. Okay. So that's basically how we do this baking and make it running around, make it going around. So this is the simple version of how we are using that nav agent to set up the destination. It's quite simple. If you think about if you want to implement that yourself, how many things you need to take into consideration? You bake the mesh, you have to detect the environment. You want to avoid the radius of the obstacle. You want to avoid the edge, and you want to plan a path, right? It's doable, but it will take you a lot of time. Here in the Unity, because that's the fancy thing about using game engine or frameworks. So when I say frameworks, it can be, if you take a Java courses, it can be the Java framework for the web application. Okay, the fancy thing about using that is there's something you need to use, I need to use, and we have that implementation has a lot of things in common. So we take that common things out and implement that for you, and then you can just call a function object to just use that functionality. So that's the amazing thing about that. So here, you just need to remember, set the destination. Then you can kind of move the agent from one destination to another destination. Okay, and and then we will see how can we actually implement the logic of the AI when they are doing idle, when it's doing patrolling, when it's find the enemy, how it will react to that. So we will use kind of a combination of the behavior tree and the state machine to implement that AI. We will talk about on next Tuesday. And meanwhile, I will also publish the project too. Please take a look at the requirements of the project too. And you can play around. You can go through this project and play around with the baking, the navigation agent. Okay, you'll have a lot of fun there. All right, thank you for coming today.